Hi, today we are going to deploy ETL pipeline on production environment using Docker, Airflow, and Weather API EC2 instance. This is ETL pipeline with a persistent staging area. So uh, this is staging area means the staging storage or staging table to store low data set. The reason I chose this architecture is because to preserve raw data when the downstream task fails, like uh, if one of the tasks failed during the ETL process, and you're probably gonna lose the low data set. So to prevent this, I initially store low data set into staging table first, and then after that we proceed the rest of the downstream task to store the data into the master tables. We have a two ETL pipeline. In first ETL pipeline, I extract the weather API data and then transform a little bit about the types of the data set and then load it into the staging table. In the second ETL pipeline, we extract the raw data from staging table and then transform the data set. Most of the time it will be data type transformation and then load it to the master tables. This is this API response. You got response. Within the response you have a body, and then within the body you have items. Inside of the items you have an item that is the list, and within the list there are the values which has a base date, base time, category, which is the types of weather conditions like temperature, humidity, or etc. And then XY coordinate, which is the location, and then observed value of per category type. The last destination is the database, and then we have a within the database we have a the tables which has a fact and 4-dimension tables. The fact is most likely the measurement value, and then in this case you have a weather uh, value per category like temperatures, odors, humidity, or rainfall, or wind speed. All this value will be stored in the fact tables. And then another dimensions are like explaining the context of the measurement values, such as uh, date and time and the location and category. So our ETL should be mapped from source to the target tables. First thing we need to do is setting up local environment. Unlike previous video, we are going to set up the project with the Docker environment. Go to the Docker, and then you can download Docker desktop based on your operating system. You can run the Docker desktop here, and then in your project directory you need to create virtual environment. And today's session you need Python 3.12.9. So to do that I will create virtual environment using PyEnv. When we install our custom packages in the environment, we need to make sure that all the libraries and packages are compatible with Docker environment. So that's why we are using the Python 3.12.9. We can go to Airflow document. We need to fetch Docker Compose YAML file. you copy here, paste, then you will see Docker Compose file here. Also, the next step is you are creating directories for this environment. Copy all this code here and paste. So we see the new directory was created. You can see the next command is we need to initialize the database. Initialization done. Now we can start Docker containers by using this command. Airflow password airflow. To deploy in the production environment, you need to make some modification. To make it production environment, you need to use the custom Docker image for the Airflow web server. So you need to uncomment this one and build from current directory. So to do that, you need to create one Docker file, because we need to install the custom libraries, so we need this custom Docker file. Another thing is we need to create one more Postgres database for the storage. This is a metadata store of Airflow. So when you are sending the XCOM communication, XCOM push or XCOM pull, they're using this one. And if we maybe modify or store our dataset in this Postgres DB, initially it will be okay, but if data volume is bigger and bigger, then it's gonna be slowed down or it will be affect to the entire Airflow. I wanna create one more Postgres database to store our dataset. One more called app Postgres. So almost the setting is similar, but your Postgres user is now weather password also, but the database also weather DB. Also you need to create the volume here, add Postgres DB volume, and then it's mounted to here in the container. And also you need to make sure the port, because default port for Postgres is 5432, but as you have a two Postgres, you need to make it different to prevent the crash. Now the Postgres metadata store is 5432 to 5432, but your app Postgres port is 5433 to 5432. You specified here Postgres volume, so you need to make sure you're creating the volume here. At this moment we are just creating require txt. So when we see the Docker containers, now we have two Postgres containers. One is Postgres 1 and another one is app Postgres 1. So we are going to use app Postgres 1 for storing our data. Leave it Postgres-1 for metadata store. Airflow, and we can see Airflow web server running as normal. The next thing is we need to create tables in Postgres database. To do that, we need to first make a schema. We are creating one file called create tables.sql. We are going to set up a first ETL pipeline. So I'm going to create a staging table schema first. This is the staging table structure. We call the DB name is staging weather, and we called staging ID, which is the surrogate key that increment automatically from 1. We define the row underscore JSON column to store JSON object. It should not be null. And then base date and base time and nx and y. The reason we are not just storing only raw dataset is because fast processing. And we added load time step and processed for the cleaning process. Check the container ID here. Web app postgres container ID. Copy. Make sure we have a create tables.sql file in the same directory we are in. Then docker copy create tables.sql this container, and we store root directory. And then we copied this file into the container, and then we can launch execute this file to create the staging table. To do that, use this command in the PSQL. And then we can see staging weather table is created. Now the table is created, so we need to start creating first ETL pipeline. So within the deck directory, import libraries, then we need to define deck. Within the deck, we define task. Then we can define dependencies. Define the default argument here. Define the deck here. Create name of deck, and you get the default argument from here. And start date. Your schedule interval is cron expression. Within the deck, you need to define the task and dependencies. Fetching data from API. The second task is processing the data to load to the staging table. And the last task is loading the transformed data to the Postgres staging table. You need to specify the order of the task. Fetching the task first, then process task, then later the load data to the staging table. And you need to specify the logic. Within the deck directory, you need to create one folders called script. And inside the script, you can create extract.py, also transform.py, load.py file. And we are going to define the callback function in this Python file. To make those as the package, we need to put init underscore .py. Python will recognize this is the module. Also, we need to import libraries. And we define the fetch weather data function we were going to use in the first task. To explain callback function, to define the session, to call the request, to prevent the API call failure, we need to add the logic for retry. We have a total 3 times of retry. Adapter should be HTTP adapter using this retry strategy. Session mount HTTP with adapter. We are going to call multiple API based on different location. We have a 4 XY coordinate, which is 4 different location in South Korea, stored in the parameter, and we are trying to send the request. Then when we get the response, all these categories and readings and measurement values, we need to append a JSON object, which is raw data, date, and time, and XY coordinate together in the list. Then we using the proper error generation. We are using XCOM to send this value to the metadata store for the next task. We define the process weather data for the second task. We need to get the output of first task from XCOM using XCOM pool. Then we get the weather data, and then for items in the weather data we have a raw JSON base date, base time, nx, ny, and then we transform this to be stored in the Postgres database, and then process data to append here and return it. And then last task is loading to staging tables. This time we need to import Postgres hook, get the data from second task using XCOM pool, and using the Postgres hook we can insert many rows into the staging. You need to specify the Postgres connection ID, create weather connection in Airflow web server UI. We defined all the necessary the functions: import, like normal packages, script, extract, fetch weather data, transform, and process weather data, script load, stage weather data. So now we can check every callback function loaded correctly. And if we go to the Airflow UI, localhost, we can go to admin, connections, add new record. Connection ID should be, connection type is Postgres. Host should be the app Postgres, because now we are communicating across the containers. And database should be weatherdb, login, weather, password, port 5432, because we are using the communication within the container, so we define the container port is 5432. Save. Let's go to DAG. So now we successed until the last task. Let's check whether the data is loaded correctly. To do that, we need to connect the DB interface tool called dbber, new database connection here, and click Postgres. Next, specify host name is localhost, database name is weatherdb, username weather, password weather, and port should be 5433, and finish. And try to connect database weatherdb schema tables, staging weather, we can see data loaded correctly. Now we can create second tag that is dependent on the first tag. So to do that, we need to create new file, main.py. Default argument define tag. Specify the first task, which is wait for upstream using external task sensor that listen the first tag to be finished. Extract data from staging table, transform data and load it. After loaded, we need to do the post-processing for staging table define dependencies. Also, we need to define the callback function in the script. So first task, to listen the previous tag, we need to specify the external tag ID, which is this one. External tag ID should be same as this one. And then external task ID, we need to specify the last task stage weather data. It should be the same as this one. When we are listening, we also need to specify the timeout. And also you need to make sure that the schedule interval should be the same as this tag and also the previous tag. If not, external task sensor task will not execute it forever. The second task, we are extracting the data from staging table. We need to specify task ID and connection ID and SQL query. We should select all the argument from staging weather where the process equal false, which means not processed raw data. We need to transform the weather data. To do that, we need to specify the callback function in the transform. We need to also define the category mapping and holiday date, which is Korean holiday date, and also the location context, the transform weather data for transformation task. To explain the transformation function, we are pulling the data from previous task, raw data from staging table, and we set the logic whether there is a staging data or not, and we define the transformed data. If the data exists, and for row in the staging data, we can get this JSON object to the weather data. We transform this base datetime object to the string, and also we need to check the holidays. We can append this data into the transform data dimension date. We stored in dim date. Also the same dimension time, also the location. Refer the location context we defined earlier. We need to match the extracted XY data to the reference tables from context. If that is matched, district code and city name and sub address in the location context to be stored in the location match. If the location match this data exists, we parse, we store the data in dim location. Also in the dimension category, we need to refer from the category context. So we get a category and observed value from weather data we got from staging table. If this category is in the category mapping, get the context of this category, like description and also unit of measure, and we put into the dimension category. Also the fact weather table, we need to prepare base date and base time and x and y for reference purpose, as well as the category to store the measurement value in here and append. Also we need to append the processed ID for the post-processing the staging table. Then everything appended in here, we can send the transformed data using the XCOM push for next task. The next task is loading data into the master table. We need to specify another callback function. So to explain this function, we prepare postgres hook that connected in weather connection, and we get the data from previous task using XCOM pull, which is transformed data, and using postgres hook we can connect to the DB. And previous task we got the value for the dim date. We can parse base date and year, month, date, day of week is holiday, and we can make a list. And if the date value exists, and we can use the cursor insert query into the dim date table, and the name of the column, and then all the value from date values. Same logic apply here in dimension time table. Also the location dimension category. Also the reason why we load all this value in the dimension tables first is because the fact table is referencing all this, the primary key of the dimension table as a foreign key. So we need to make sure all this value in the dimension table loaded first before loading data into the fact tables. And every item in the fact weather object from previous task, and we are looping and using this base date, and we can select all those values in the dimension table, base date and date IDs, and save it into the date ID map. Also the same logic applied. We can execute to SQL query to select all those base time and time ID from dimension time tables if the base time in dimension table is in the base time in fact transformed data, and we load it. We save it as a dictionary for the reference. Also location for the category IDs, the same logic applied here, all prefetched. Lastly, we are looping all those transformed data from fact weather from previous task. Every fact from the date ID map from dimension table, then we get date ID. Base time we get time ID, and x and y get the location ID from location ID map. The category code, we can get the category ID. So we got all the IDs from dimension tables, and if all 4 ID is not null, we can append fact value, date ID, time ID, location ID, category ID, and fact measurement value, and append it to the fact values. And if fact value exists, finally we can use postgres cursor, load all this data into fact weather measurement table. In that field, all the values in fact values. Then last we are send the commit, and then we close the postgres. So this is the final logic to load the data into the master tables. Lastly, after loaded, we need to do the post processing, that data, whether data is processed or not. To do that, we need to create another script. Maybe you can say utils. You can import postgres hook, define the function mark processed. You define the postgres hook, and then get data, transformed data. From transformed data, you get the processed IDs. If processed ID exists, you can update staging weather table and set the processed attribute to be true, where if the staging ID is any in the processed IDs. So if that condition met, and you can set the process to be true. You run the postgres query using these parameters. So to be those callback function work, we need to import this script. Everything should be work properly. I installed all the packages for this project, so I will use pip freeze then let's see. Yeah, everything's stored. Another thing you need to do is also create master tables. We can create the master tables, dimensions and fact tables. Dimension date, we have a date ID, base date, it should not be null, and year, month, date, day of week is holiday. And also time dimension, we have a time ID and base time and hour. Also the location ID, we have a XY coordinate, and we have a context of the, based on that location we have a district code, city, and sub address, effective date, expiration date is current. Also dimension category, we created a category ID, category code, and explaining category code we have a description in unit, and also effective date, expiration date is current. And lastly, we have a fact weather measurement table to store the measurement value. We store here measurement value. Also we create date ID, time ID, location ID, category IDs from dimension tables. So we can create the primary key as a composite primary key from all these dimension tables, and we need to specify foreign keys from all the dimension tables primary key. Yeah, so this is the table, and we can create these tables again. Use docker ps. You can check the app postgres container ID. We can copy docker copy into this container location, and copy it, and we can execute. So we created 2, 3, 4, 5, 6 tables. Okay, so we have all the tables we need. Flow UI. These two decks are created and we are running. The first pipeline success, and then second pipeline is listening the first pipeline. Second deck also success. So let's see whether the data stored correctly. If we go to the dbeaver, now we can refresh. We can see the new tables created. Staging weather, we can refresh. 192 categories, dimension date, location, time ID, lastly the fact tables. Now we created two ETL pipelines in local environment, so now we are ready in cloud environment. We need to push our code into the GitHub repository. I already created my GitHub repository. You can add all this file. You can send all this code into the master branch. Now we're gonna pull this code into the AWS EC2 environment. We can go to the AWS. Now we are in AWS console and launch instance. Give an instance name. Select Ubuntu. Change the architecture to ARM, and you can select the T4G.large. You need to have at least 8 GB memories. The reason why I use ARM architecture is because of the instance cost. I noticed that T4G.large is most cheapest instance which meet the minimum requirement for the production, lowest price for on-demand Linux pricing among other instance which has a 8 GB memory. You might wonder whether the Docker images are compatible with ARM architecture. I tested working properly, and then we can generate key pair, create the key pair, network setting, we can click everything, and also configure storage. You can select maybe 20 to 30 GB memories, and launch instance, elastic IP, allocate elastic IP, allocate, and associate elastic IP address. You can select from here and associate the elastic IP, allocate it, and go to instance detail, go to security, and go to security groups here, and edit, add the role, custom TCP, make sure port number is 8080, save the role. AWS EC2 instance is running. Okay, now we are in the AWS EC2. We need to install the Docker inside of the Linux. So we can go to the Docker official documentation and install Docker engine on Ubuntu. So we are gonna using apt to install the Docker in Ubuntu. This, copy, paste the Docker package from here, copy and paste. Yes. Test Docker PS, and you have a probably encounter the permission issue, the continue to post installation steps for Linux, Ubuntu to the group, copy, paste, and so copy, paste, and log out, login again, connection closed, and connected again, and then see, now we can run docker command without any sudo command. Pull my GitHub repository here, and we can clone. So we can see all this file. We need to create this directory first. Make sure all the required packages installing. Now initialization done, we can run the command for running the containers. Containers are up, so we can go to port 8080. Before running, we need to create connections here. Whether connection is postgres, database name is weatherdb, port. So created connection. We need to create the tables. This container ID, add postgres, copy container ID, docker, copy, to postgres, okay. So we can see all tables are created. I think it's all ready. Let's start. Pipelines are running, and when we go to the first pipeline, our deck runs successfully. Then we can see the second pipeline. We are listening the first deck to be completed, and it's completed. Second, third, fourth, and the last one. Everything run successfully. We can check whether data is loaded correctly. We can go to dbeaver, and now we can create another connection, postgres. Next, we can go to the SSH using SSH tunnel, host IP, copy, public IP, and then username is Ubuntu. We are using public key. You can use this, and then go to the main, weatherdb, weather, password, weather. save. You can go to the tables, new data loaded here. Use this one for production environment, especially when you are collecting the data from API. So now you have a stable data pipeline. Also, one thing I need to share is the memory usage, because you can see here that minimum memory requirement for the Airflow Docker Compose file is around 4 GB memory. So if you're using the 4 GB instance, you will not really run pipeline properly. So I recommend you to use at least 8 GB memory instance. That's it. I hope you are enjoying my video. If you like the video, please subscribe. Wait for the next video. Thank you.